Hello and welcome to Engineers Mindset Academy. Alright, so I'm putting out this video specifically to all my 200 level engineering students within the Rivers State University, Port Harcourt, Nigeria, who are preparing for their forthcoming examination. So this particular video targets 2021 past question review on Engineering Mathematics 206. Okay, and I hope this video helps you in one way or the other to excel in your forthcoming examinations. And to all my viewers worldwide, I hope you also learn a lot from this video and become better in your engineering mathematics. So this particular video targets the very first question, and in the subsequent videos, of course, we'll release the remaining questions as well. All right, guys. So without wasting much time, if you're new to the channel, please do well to always like our videos, comment, and of course, subscribe to the channel. Let's get straight to the video. Thanks. All right, so let's consider the first question. Question 1 says, a tailoring firm can produce two types of clothes, A and B, using a sewing, cutting, and embroidering machine. The product yield a contribution of 8 naira and 2 naira respectively. The sewing machine has 3 hours capacity, with each cloth unit using 3 hours and 1 hour respectively of the capacity. There are 6 hours capacity for the cutting machine, with the cloth unit using 4 hours and 3 hours respectively of this capacity. The embroidery machine is available for only 4 hours, with each cloth unit using 1 and 2 hours respectively of the machine's capacity. If the company wishes to find out the production plan which maximizes its contribution, the first question says, state all the equations and inequalities describing the production process. The second question says, sketch the inequalities and sketch the feasible region on your answer booklet. The third question says, how many of clothes A and B should be produced to maximize its contribution? And the final question says, what is this maximum contribution? Alright, so this is actually a question on linear programming. So we are working with question 1. Okay, question 1. Now let's start with the first question. First question says, state all the equations and inequalities describing the production process. Okay, state all equations and inequalities describing the production process. All right, so the very first equation is the objective function. The first equation there is the objective function. All right, and what is the objective? To maximize profit. Okay, to maximize profit. This is the objective, and to maximize profit from contribution. Okay, from contribution. All right, so the first equation is the objective function, which is actually to maximize profit from the contribution. And what is the contribution? So if you read through the question, you see that the question says the product yield a contribution of 8 naira and 2 naira respectively. Now, what are the products? First of all, the products are A, clothes A and B units. Okay, clothes A and clothes B units. These are the products. Now, the objective function is symbolized by Z, and this is equal to So the objective function is to actually maximize profit from the contribution 8 naira and 2 naira of this product respectively. So which means 8 naira goes for product A and 2 naira goes for product B. This is now the objective function. So you have 8A plus 2B. So this is the first equation. Call that equation 1. That's the first equation. All right, the next equation is can be obtained by formulating the constraints of each of the machines. Okay, so you have the constraint equation. You have the constraint equation for each machines. All right, the constraint equation for each machine. Let's start with the sewing machine. So you have for sewing machine, remember we are given. Now let's go back to the question. Question says the sewing machine has 3 hours capacity with each cloth unit using, so maximum capacity is 3 hours. Okay, maximum capacity is 3 hours. Okay, 3 hours max. That's the capacity of the sewing machine. Now with each cloth unit, using 3 hours and 1 hour respectively of the capacity. So each of the cloth units, what are the cloth units? Remember, A and B are the cloth units. So with each cloth unit using 3 hours and 1 hour respectively of this maximum capacity. So which means for the first cloth unit A uses for 3 hours. So you simply call that 3A, and B uses 1 hour. You can call that 1B, which is also B. So representing this inequality, it means that 3 hours for cloth A plus 1 hour for cloth B must be less than or equal to the maximum working capacity, which is what? 3 hours. So which means it cannot exceed what? These 3 hours. All right. So you can simply rewrite this equation as saying 3 hours working unit for cloth A plus 1 hour for cloth B. Now 1 times B will remain B, must not be greater than, so it's either less than or it must be equal to 3 hours. So you can call this equation 2. So this is the second inequality or equation. That's the second inequality or the second equation. That's for the sewing machine. Now let's consider for the cutting machine. For cutting machine, okay, let's move back to the question now for cutting machine. Okay, the question says there are 6 hours available for the cutting machine with the cloth units using 4 hours and 3 hours respectively of this capacity. So which means maximum capacity for the cutting machine is what? 6 hours max. Now with each cloth unit using 4 hours and 3 hours respectively, which means remember the cloth units are what? A and B units. So 4 hours for cloth A and 3 hours for cloth B respectively. So let's formulate the equation. This is simply now saying that the maximum working hour capacity of the sewing machine is 6 hours. Now, individually, the cloth units combine with what? 4 hours, 4 production hours for cloth A. So you have 4A plus 3 production hours for cloth B. You have 3B. And this must not be greater than. So you simply have the whole of this will be less than or equal to what? 6 working hours for the cutting machine. So this is the second inequality equation. Call this equation 2. Okay, now for the embroidery machine, okay, for embroidery machine, okay, let's go back to the question for the aspect of the embroidery machine. So the embroidery machine is available for only 4 hours, with each cloth unit using 1 hour and 2 hours respectively. Available for only 4 hours. So the maximum hour is 4 hours. Each cloth unit uses 1 hour and 2 hours respectively. So 1 hour for what? Unit A. You have 1A and 2 hours for unit B respectively. So let's formulate the equation. Now you have 1 hour for A plus 2 hours for B. This must not be greater, so less than or equal to what? 4 hours. So if we write this equation, of course, 1 times A will remain what? A plus 2B less than or equal to 4 hours. This is the third equation, or the third inequality that governs the whole production process. And the final equation is what is called the non-negativity equation. The final equation is called the non-negativity equation. Okay, the non-negativity equation. This is the final equation. Since each production unit cannot produce a negative value, so we have the non-negativity equation. Since each production unit cannot produce a negative value, therefore you simply have that A can only be greater or equal to 0, and B can also be greater and equal to 0, but they can never be less than 0, so it can never be negative. So this is the first question answer. These are all the inequalities and equations which govern the production process. So the second question says, the second question says, sketch the inequalities and sketch the feasible region on your workbook. So we are asked to sketch the inequalities and the feasible region. All right, so sketch the inequalities and the feasible region on your answer booklet. That is the second question. Now, this is quite easy to be done. The first thing to do is you pick out the constraints. That's the first thing to do. You pick out the constraints and consider boundary conditions to obtain the values of the production units A and B. That's what you do. Now, for the first case, for the sewing machine, we started with sewing machine. So let's also continue with sewing machine first here. For the sewing machine, we obtain its inequality. Let's fall back there. We obtain the inequality of the sewing machine to be equal to 3A plus B less than or equal to 3. So let's pull back this equation. 3A plus B. So you have 3A plus B less than equal to 3. This is the first equation, okay, for the sewing machine. Now, we want to actually solve. You can either solve in the inequality format, or you can simply take off the inequality and solve with equal to format. So you can simply say 3A plus B is equal to 3. Now, to find each clothing unit, you set a boundary condition. What is a boundary condition? To find B, or to find A, let's start with A. To find A, you set B to be equal to 0 in this equation. So if I'm setting B to be equal to 0, it means I have here 3A plus, in place of B, B is 0, and this is equal to 3. This simply implies that 3A, of course, plus 0 is off, and this is equal to 3. So that means I can obtain A by what? Dividing through by 3. I have 3 divided by 3, and this is equal to 1. So we have that when B is equal to 0, A gives us 1. That's the first boundary condition. The next boundary condition now is to find B. To find B, now you set A to be equal to 0 in this same equation. If you do that, this is now 3A becomes 3 times 0 in place of A plus B equals 3. 3 times 0 obviously is 0 plus B equals 3. So 0 plus B remains B. This implies that B is equal to what? 3. Now, what are the coordinates? These are the coordinates. So I have my coordinate value when A is equal to 1, we said B was equal to 0. So A is 1 when B is equal to 0. And when A becomes 0, B is equal to 3. So when A is 0, B is equal to 3. So these are the coordinates. So in what we're invariably saying is that A stands for the position of X. So A comes first and then B comes second. So A stands for the position of X and B stands for the position of Y on a graph scaling or on a graph sheet. That's if you want to plot this on a graph sheet or on your workbook. So this becomes the coordinate of the sewing machine. Next, also, we find the coordinates of the cutting machine using the same approach by setting boundary conditions. Okay, so let's pull out the equation for the cutting machine. So for the cutting machine, we had this equation 4a plus 3b less than equal to 6. All right, so for cutting machine, we also apply boundary condition on the cutting machine. We had 4a plus 3b less than equal to 6. So like I said, you can either choose to solve with the inequality sign or you can take it off and solve with the equal to sign. So we have 4a plus 3b equal to 6. Now to find a, remember, set b to be equal to 0. If you do that into this original equation, we are going to have 4a plus 3 in place of b. We say b now is 0 and this is equal to 6. This implies that 4a plus, of course, 3 times 0 is 0 equals 6. This also implies that 4a plus 0 remains 4a is equal to 6. Now to find a, we divide through by 4. Therefore, a is equal to 6 all over 4, which implies that a is equal to, of course, 6 divided by 4 will give us 1.5. So you have a to be 1.5 when b is equal to 0. Now to find b, you set a to be equal to 0 in that same original equation. If you do that, you're going to have, this is 4a, it becomes 4 times 0 plus, this is 3b, 3b equals 6. 4 times 0, of course, is 0, plus you put down your 3b, and that's equal to 6. 0 plus 3b remains 3b equals 6. Now, I need to find b. I have to divide both sides by what? 3. Therefore, b is equal to 6 all over 3, which equals what? Which equals 2. So, when a, okay, when a equals 0. So when a is 0, we obtain b to be equal to 2. So we plot the coordinates now. Let's put down the coordinates. Remember, the coordinate stands for a in place of x and b in place of y. So transposing this, okay, we are going to have for the first coordinate, when a or when b is equal to 0, we had a to be equal to 1.5. So a is 1.5 when b is 0, and when a is 0, we had b to be equal to 2. When a is 0, b is equal to 2. So this becomes the coordinate of the cutting machine. Now we find the coordinates of the embroidering machine or embroidery machine by also taking boundary conditions. So for the embroidery machine, we obtain the inequality equation. Let's go back to it. For the embroidery machine, the inequality equation was obtained as 4a plus 2b less than equal to 4. A plus 2b to be less than or equal to 4. So the inequality equation is a plus 2b to be less than equal to 4. So like I said, you can either solve with the inequality symbol or solve with the equal to sign. But let's solve with the equal to sign. This gives you a plus 2b equal to 4. Now to find a, always set B to be equal to 0, taking your boundary conditions. So you have there A plus, this is now 2 into 0, and that's equal to 4. So this implies A plus 2 times 0 is 0, which is equal to 4. So A plus 0, of course, is A. This simply implies that A is equal to 4 when B is equal to 0. Also, to find B, set A to be equal to 0 into the original equation as well. So if you do that, okay, this simply implies that you're going to have A is 0, so you have 0 plus 2B to be equal to 4. Okay, of course, 0 plus 2B remains 2B equals 4. Now I need to make B subject. I have to divide both sides by 2. This simply implies that B is equal to 4 divided by 2, and therefore B equals 2 when A is equal to 0. Hence, the coordinates, remember A, B is a coordinate. We are going to have this to be what? When A is, or when B is equal to 0, we had A to be equal to 4 over here. So when A is 4, B was given as 0. And when A is 0, we had B to be equal to 2. So B was given as 2. So these are the coordinates. So we've gotten the coordinates for the three machines. All we need to do now is plot these coordinates and determine the feasible region. Okay. Okay, so you plot a graph of A and B. You plot a graph of A and B. You plot a graph of A and B. So remember I said, okay, over here, the coordinates we have here A and B. A stands for the X axis and B stands for the Y axis. So over here are the values of what? B on the Y axis, and over here are the values of X on the, sorry, values of A on the X axis. So you have this. Now let's start with the coordinates of the sewing machine. The sewing machine has 1 0 and 0 3. Okay, the coordinates of the sewing machine are 1 0, that is when A is equal to 1, B is equal to 0, and when A is equal to 0, B is equal to 3. So A1, B0. Let's start with that. So when B is 0, this is the origin point where everything is 0. When B is 0, A is given as what? 1. So let's calibrate these points. Let's calibrate this point. We can call here 1, call here 2, call here 3, call here 4, and so on. Let's also calibrate those of B. You can call here 1, call here. Mind you, we're not using a graph sheet, so it was stated clearly. Do this on your answer booklet. Call here 3, call here 4. Okay, so for the sewing machine, once again, when A is 1, B was obtained as 0, and when A is 0, B was obtained as 3. So all we are plotting is connect A as 1, connect B as 3 together. So A1, B3 together. So we come here. This is the line for A. This is the line for B. Remember, A is 1 and B is 3. So you connect 1 and 3 for B together. Connect 1 and 3 for B together. You have this. For the cutting machine, the coordinates are 1.5 for A when B is 0, and when A is 0, B is 2. So all we are connecting now is locating A 1.5 and locating B as 2. So we move over to the graph, locate A as 1.5, locate A as 1.5. This is A. Now, if here is 1 and here is 2, it means 1.5 should be in the middle. So we have 1.5 somewhere in the middle. Okay. So A is 1.5 and B is, let's go back to it once again. A 1.5 and B is 2. So connect A 1.5 and B 2. So this is 2. This is 1.5. You connect the points together. This is 2, and this is 1.5. You connect the points together, so you have something like this. Okay, and finally, we're here for the embroidery machine. For the embroidery machine, we have A as 4 when B is 0 and B as 2 when A is 0. So all we are looking for now is connect A as 4 and B as 2. And this is A, which is 4. This is B, which is 2. So you connect these 2 points together. 4 and 2. You connect these points together. Now the area or the region or the area under which these 3 points connect and falls under, the area under which these 3 points connect, the area under which these 3 points connect is what gives us the feasible region. So I have that the 3 lines 1, 2, 3 intersect and falls under what? This area. So you can shade these points, you can shade this region. This region is called the feasibility region because it is here that, okay, this is the area under which the 3 lines intersect one on another. So this is the feasible region. That's the feasible region. Okay, so that's that question answered. Now the third question says, how many of clothes A and B should be produced to maximize its contribution? How many of clothes A and B should be produced to maximize its contribution? All right, so to solve this question, the first thing is to pick out the objective function. Not forgetting earlier we stated the objective function. Okay, so we'll pick out the objective function. That's the first thing to do. All right, and the objective function, remember, let me take us back to where we had the objective function. That was the very first equation which we got. Okay, where we said z equals 8a plus 2b. This is the total contribution and we want to maximize this contribution now. So objective function z equals 8a plus 2b. So we're going to be keeping this equation aside because we're going to need this equation for this analysis we're about to do now. Now, in order to find how many clothes A and B should be produced to maximize this profit, then we need to now look over the graph we obtained earlier. If we look over the graph beyond at the feasible region, notice now that the sewing machine intersects with the cutting machine. The cutting machine intersects with the embroidery machine, and the sewing machine also intersects with the embroidery machine. So we need to find their intersections. So we find the intersections of the machines with one another. So let's start with sewing machine. Intersection of sewing machine, okay, with cutting machine. We can start with this. All right, so to get this intersection, we'll find or we'll pull out their constraint equation. The constraint equation for the sewing machine, we had that earlier. Okay, for sewing machine, the constraint equation was given as 3a plus b equals 3. So you put it out, 3a plus b equals 3. Call this equation 1. And the constraint equation for the cutting machine, now we're about to look for their intersection. For the cutting machine, we had that's 4a plus 3b equals 6. For the cutting machine, okay, so we have 4a plus 3b equals 6. So 4a plus 3b equals 6. Call this equation 2. Alright, so all we need to do now is obtain the values of a and b so by solving these two simultaneously. We find the values of A and B for the intersection between the sewing machine and the cutting machine. Okay, so to do this, the very easier way to always solve a simultaneous equation is elimination method. For me, I think it's best. And what is the elimination method? I want to eliminate B, or I want to eliminate A. Okay, let's say I want to eliminate B and find the value of A. The coefficient of B in equation 2 is 3, whereas the coefficient of B in equation 1 is just 1. So what I will do is I will multiply equation 1 by the coefficient of B in equation 2, then multiply the whole equation 2 by the coefficient of B in equation 1. Since the coefficient of B in equation 2 is 3, I'll multiply equation 1 by that 3, just because I want to eliminate B. And since the coefficient of B in equation 1 is 1, I'll multiply the whole of equation 2 by 1. Okay, so if I do this, I'll have 3 multiplying everything in this equation. So 3 times 3a here gives me 9a, plus 3 times 3b gives me, 3 times b gives me 3b, and this is equal to 3 times 3 gives me 9. Call this equation 3. Also, 1 times everything here remains. 1 times 4a remains 4a, plus 1 times 3b remains 3b, equal to 1 times 6 remains 6. Call this equation 4. Now I can subtract these two equations. So simply remove equation 4 from equation 3. I have here 9 minus 4, that gives me 5a. Okay, that gives me 5a. Now, plus 3b minus 3b gives me 0. See, notice now that b has been eliminated, and that's equal to 9 minus 6 gives me 3. So this implies that 5a is equal to what? 3. And therefore, I can find a to be equal to 3 divided by 5. Okay, so from here, 3 divided by 5 will give me the value of a. So let's get the decimal equivalent of that value. 3 divided by 5, each decimal equivalent is 0.6, so it means that a is equal to 0.6. Okay, now if a is 0.6, you can use substitution method at this point, put in the value of a into any of the equations and obtain the value of b. So let's put into equation 1, so substitute a, which is equal to 0.6 into equation 1. So if you do that, remember equation 1 states 3a plus b is equal to 3. So this simply implies 3. Remember, a now is 0.6 plus b equals 3. So 3 times 0.6 will give us, okay, times 3, that gives us 1.8. So we have a 1.8 plus b is equal to 3. So to make b subject, simply send 1.8 the other way around. This implies that b equals 3 minus 1.8. Of course, plus 1.8 cross an equal sign becomes negative, and therefore b equals 3 minus 1.8. That gives us 1.2. So we have this to be equal to 1.2. Alright. So the intersection of the sewing machine and the cutting machine give us A, B to be equal to A was gotten as 0.6 and B was gotten as 1.2. You keep this aside. Next, you find the intersection of the sewing machine to the embroidery machine. Okay, so we find intersection of sewing machine to embroidery machine. Okay, and to do this, you quickly pull out their equations. So let's go back to the equations once more. The equation for the sewing machine remains 3a plus b to be equal to 3. So always, let's call this equation 1 for the machine, and for the embroidery machine, Okay, over here we obtain for the embroidery machine that a plus 2b is less than or equal to 4. So simply saying a plus 2b, okay, equals 4. So call this equation 2 for this intersection. Just like we did above, we also find the values of a and b in this equation. Alright, so I can still choose elimination method. Let me eliminate b. Hence, since the coefficient of b here is 2, I'll multiply equation 1 by 2 and multiply equation 2 by 1, which is the coefficient of b in equation 1, multiply by 1. If I do this, 2 times 3 gives me 6a, plus 2 times b gives me 2b, and that's equal to 2 times 3 gives me what? 6. Same thing, 1 times a here remains a, plus 1 times 2b remains 2b, equals 1 times 4 remains 4. So this is equation 3 and this equation 4. Now, if I have these equations now, next thing is to subtract. So once I subtract, 6a minus a remains 5a, plus 2b minus b remains 0, and that's equal to 6 minus 4 remains 2. Okay, so this simply implies that from here I will have that 5a plus 0, of course 0 is off, is equal to 2. This implies that a equals 2 all over 5, and therefore a in decimal place becomes 2 divided by 5. Okay, 2 divides by 5, that gives us 0.4. So a is 0.4. So if I know a, I can choose to substitute into any of the equation. So substitute a equals 0.4 into, let's also use equation 1, and from equation 1 we have 3a plus b is equal to 3. This implies that 3 a now is 0.4 plus b equals 3, and this implies that 3 times 0.4 gives us 1.2. So we have 1.2 plus b, okay, plus b equals 3. To make b subject, I'll simply send 1.2 over here. So this simply implies that b becomes now 3 minus 1.2, and b is equal to 3 minus 1.2 will give us 1.8. So we have b to be 1.8. So for the intersection of the sewing machine and the embroidery machine, we obtain a as 0.4 and b as 1.8. So let's put it down somewhere. So for that intersection, we had a and b to be equal to 0.4 and 1.8. Okay. Alright, so that gives us the intersection of the sewing machine and the embroidery machine. So if we know this intersection now, next we can now we found intersection of sewing machine and cutting machine, intersection of sewing machine and embroidery machine. So what is left now is the intersection of the cutting machine and the embroidery machine. So we find that intersection of cutting and embroidery machine. Okay, so we find the intersection of cutting and embroidery machine. So what is now their intersection? Obviously we'll go from their equation. The equation or the constraint equation for the cutting machine we have here to be 4a plus 3b equals 6. So it becomes 4a plus 3b equals 6. This for cutting machine. Call this equation 1. For the embroidery machine, okay, for the embroidery machine over here we had it as a plus 2b equals 4. So we have a plus 2b equals 4. Call this equation 2. Now I will also choose elimination method. Now let's try and eliminate okay, let's eliminate b just as we've been doing, just to be consistent. The coefficient of b in equation 2 is 2, whereas that of b in equation 3 in equation 1 is 3. So I will multiply equation 1 by the coefficient of b in equation 2, which is 2. So I will multiply the whole of equation 1 by 2, multiply the whole of equation 2 by 3, the coefficient of b in equation 1. Alright, so if I do that, 2 times 4a gives me 8a plus 2 times 3b gives me 6b equals 2 times 6 here gives me 12. Call this equation 3. Then I'm multiplying equation 2 now by 3. 3 times a gives me 3a plus 3 times 2 gives me 6b, and that's equal to 3 times 4 gives me 12. Okay, so this is now equation 4. So I can now eliminate subtracting. If I subtract both sides, 8a minus 3a gives me 5a plus 6b minus b gives me 0. 6b minus 6b gives me 0. That's equal to same thing here. 12 minus 12 obviously gives me 0. So this implies that 5a is equal to 0, and therefore a is equal to 0 all over 5, which implies that a is equal to 0. For this intersection, a is equal to 0. So we can now substitute a into any of the equations. Substitute a equals 0 into equation, okay, let's choose equation 2. Into equation 2, if you do that, I have here now, in place of a, equation 2 says a plus 2b is equal to 4. So in place of a is 0 plus 2b equals 4. Of course, 0 plus 2b, 0 is off. I have 2b equals 4. Therefore, make b subject. It becomes 4 divided by 2, the coefficient of b. So I have 4 divided by 2. So this implies that b itself is equal to what? 2. Hence, the intersection between the embroidery machine and the cutting machine give us AB to be equal to A is 0 and B is equal to 2. We have this. So these are now the intersections. Let me pull out all the intersections that we've gotten so far. For sewing and cutting machine, we had our intersection to be, for the sewing and cutting machine, we had our intersection to be 0.6 and 1.2. Okay, we had the intersection to be 0.6, okay, and 1.2. Okay, for sewing and the embroidery machine, for sewing and embroidery machine, we obtain our intersection to be, okay, it's over here. We obtain it to be 0.4 and 1.8. We obtain it to be 0.4 and 1.8. Finally, for cutting and embroidery machine, we obtain our intersection here to be 0 and 2. Now these are the intersections of each of these machines with one another. We can now substitute these values into the profit or into the objective function. Remember, recall z is equal to 8a plus 2b. So let's start with the first case now. For sewing and cutting machine, we had, okay, for sewing and cutting machine, is our values for a and b. We had a to be 0.6 and we had a to be b. So we now substitute each of these values into this function and see the one that gives a higher value towards the objective function. Okay, so for sewing and cutting, z is equal to, we said 8 and a for the sewing machine gave us 0.6, so we have 0.6 plus 2b, and b gave us 1.2, so 2 times 1.2, we have c to be equal to 8 times 0.6, 8 times 0.6, this gives us 4.8, okay, plus 2 times 1.2, that's 2.4, so this implies that z is equal to 4.8 plus 2.4, that gives us 7.2. Alright, so when for the intersection between the sewing machine and the cutting machine, we had our profit margin to be 7.2. We move over for sewing and embroidery machine. Okay, we also find z, we said is 8a plus 2b, and that's equal to 8. For the sewing and embroidery machine, we obtain a to be 0.4 and b to be 1.8. So we put that value down here. So 8a, a is 0.4 plus 2b, and b is 1.8. Okay, this is now equal to, so 8 times 0.4, we obtain 8 times 0.4, that gives us 3.2. Okay, plus 2 times 1.8, that gives us 3.6. We have 3.6. Okay, so this implies that the z value becomes 3.2 plus 3.6, that gives us 6.8. So we have 6.8. So the profit margin or the objective function z gives us 6.8 when we consider sewing and embroidery machines. Okay, finally we now find for the cutting machine and embroidery machine. For cutting and embroidery machine, okay, remember z equals 8a plus 2b, and that's equal to, for the cutting machine and for the embroidery machine, we had a to be 0 and b to be 2. So this is now equal to 8, a is 0 plus 2, b is 2. This gives us 8 times 0 obviously is 0 plus 2 times 2 is 4. This implies that z is equal to 0.0 plus 4 remains 4. So comparing the three values of z, for sewing and cutting machine, we had z to be equal to what? We had z to be equal to 7.2 here. For sewing and cutting machine, we had z to be 7.2. And for sewing and embroidery machine, we had z to be what? 6.8. So notice now that 7.2 is the largest amongst the three. We have 7.2, we have 6.8, and then we have finally here 4 for cutting and embroidery machine. So this simply means that the one that yields a maximum profit is what? 7.2, and that is when we produce when the number of clothes produced becomes 0.6 for A and 1.2 for B. Hence, the number of clothes that will yield maximum profit, that will yield maximum contribution are, okay, so we had the maximum contribution to be 7.2 when A is 0.6 and B is 1.2. So A equals 0.6 and B equals 1.2. So we need to produce 0.6 clothes of A and 1.2 kilos of B to yield maximum contribution. Alright, so that's the answer to that question. Okay, so the final question V says what is the value of this maximum contribution? What is the value of this maximum contribution? Alright, we don't need to solve. We've already found it at the value of the maximum contribution under the given condition is when Z equals 7.2. That's the highest value of the contribution obtained. So the value is 7.2. We've already solved for it above. Okay, that's over here. Z equals 7.2 for the sewing and cutting machine intersection. Alright guys, so that's the solution to that particular question. Alright, so I will see you in the next video. Thanks and cheers.